Everyone, welcome to this session on wedge friction, and this is the problem wherein one particular wedge has been placed on the inclined surface and the block has been placed on the horizontal surface. The statement of the problem goes like this: determine the force P required to start the wedge as shown in figure. So force P is been applied on this particular block, so this block will be called as wedge now. And wedge is basically an object that has been used to move or to lift an object from its original position so that the realignment and repositioning of the element can be placed. So this particular 100 kilonewton block needs to be realigned, it needs to be shifted from its original position. So wedge P is been subjected to a force, wedge has been subjected to a force P. Now as the direction of the force P is downward, which indicates a wedge will move in the downward direction. If we happen to draw the Freebody diagram of the wedge, so as the force P is in downward direction, object will move along the direction of the force impressed. As the force impressed is in the downward direction, impending motion is in downward direction, so frictional force will be always opposite to the moment of the body. So important thing is the wedge moves in the downward direction. As wedge moves downward, the position of the 100 kilonewton block will shift towards the right hand side. As this proceeds in the downward direction, this particular block will gradually move towards the right hand side. So the moment of the impending motion of 100 kilonewton block will be towards the right hand side, whereas the moment of the wedge will be direction of impending motion will be in the downward direction. So considering this particular case wherein the moment of the wedge is in downward direction and 100 kilonewton block will move towards the right hand side. So first there are six steps that we need to follow now. So first step is we need to draw the free body diagram. Next is we need to show the self weight if it has been given. If it has not been given, then the given forces shall be considered as it is. Generally the wedge is a lightweight object, and if the weight is not been given, the weight of the wedge needs to be neglected. Then direction of the normal reaction will be always perpendicular to the plane of contact. That means it will make 90 degrees to the plane of contact. Next one is the direction of the frictional force. So direction of frictional force will be opposite to the movement of the object. So which indicates if the direction of the frictional force, now here direction of the body is in downward direction, so frictional force will be opposite to the movement of the body. That means it will be acting in the upward direction. Here direction of impending motion 100 kilonewton is towards the right hand side, so frictional force will be opposite to the movement of the body. Then frictional force will be always mu times of n. This particular thing needs to be remembered now. Then the important thing is the resultant reaction force component. Resultant reaction force component will always make an inclination of phi, that is angle of friction phi, with respect to the normal reaction. For this problem, the angle of friction is been given as 15 degrees. So instead of coefficient of friction, angle of friction is been given as phi of n. So phi value is considered as 15 degrees. So we shall start with this particular first to draw the free body diagram. To draw the free body diagram, isolate the object now. Isolation of the object means the first object is nothing but the wedge which has been placed at this location. Next object is nothing but the block which will be placed at this particular location. That means isolating the body which is in contact with the surfaces and then representing all the forces acting on the body. So force P is being subjected in the downward direction, which indicates direction of impending motion is downward. So frictional force shall be shown in the upward direction. So frictional force here, this particular wedge is in contact with the block and with respect to the surface here. So wherever there is a contact surface, unless it has been mentioned as smooth, you need to show the direction of the frictional force. If it has been mentioned as smooth, then coefficient of friction needs to be taken as 0. But in this particular problem, there is none of the surface which is being mentioned as smooth. So as a result, all the coefficient of friction shall be considered as it is. That is, the frictional force shall be considered as it is. So coming on to the statement here, if the force is acting in the downward direction, so that means the body will be moving in the downward direction, then frictional force will be opposite to the movement of the body, so frictional force will be subjected in the upward direction. So this will be the direction of the frictional force. Now this frictional force direction I shall call it as f of f1 at the first phase. At the second phase I shall call it as f of f2. Then at this particular location, at this phase, as the frictional force here is upward, on this particular junction, frictional force will be equal in magnitude and opposite in direction. So frictional force shall be shown in the downward direction. So here it will be plus of f of f2 minus of f of f2. The net resultant force along these two faces shall be 0. Now this is a friction force pertaining to 100 kilonewton block. Now we need to show the friction force for 100 kilonewton block. Now as this particular block proceeds in the downward direction, 100 kilonewton block will slide towards the right hand side, that is direction of DIM. DIM means direction of impending motion will be towards the right hand side. If direction of impending motion is towards the right hand side, frictional force shall be shown towards the left hand side, and this frictional force we shall name it as F of F3. So this will be the direction of the frictional force which will be always opposite to the moment of the body. So free body diagram has been drawn and the frictional force has been drawn. Now coming on to the direction of the sulfate now. Now usually the sulfate is not been given for the wedge, you can leave it now. Now coming on to the direction of the normal reaction. Now direction of the normal reaction, this particular block is being placed on the inclined plane. So whereas this particular 100 kilonewton block is placed on the horizontal surface. For better understanding, we'll draw the normal reaction for this force component. So reaction will be perpendicular to the plane of contact. So this will be 90 degrees to the plane of contact here. And this reaction component I shall name it as N3. Likewise, here again there will be a normal reaction force component. And normal reaction here, as the surface was horizontal, reaction was vertical. Now here surface is inclined, it will neither be horizontal, neither be vertical, it will be perpendicular to the plane of contact, that is it will be making 90 degrees to the plane of contact. If it makes 90 degrees to the plane of contact here, this inclination is already 75 degrees, which is the given inclination. This is 90 and the left out angle will be 15 degrees. How to calculate this? This will form a right angle triangle which will be 180 minus of 75. So then minus of 90, which will come out to 15 degrees. So this inclination that will be formed is 15 degrees. The same 15 degrees will be transferred here. So normal reaction will make an inclination of 15 degrees to the plane of contact. If we draw x and y axis for the given diagram, to draw x and y axis, we shall project this particular y axis and project x axis. Project y-axis and project this particular x-axis. Now coming on to the direction of the normal reaction force component. Normal reaction force component is perpendicular to the plane of contact here. It is 90 degrees. This inclination is 15 degrees here. And frictional force is upward. The normal reaction is upward, which will make the inclination of 15 degrees to the plane of contact. 15 degrees, this is 75. This is 90. 90 plus 75. 90 plus 75 shall come out to 165. So 165 minus of 180, because it will form a right angle triangle, minus of 180, which will be nothing but 15 degrees is the inclination that has been formed with respect to the horizontal plane. If 15 degrees is formed with respect to the horizontal plane, with respect to x-axis again it shall be 15 degrees. So that is the reason why normal reaction, as this is f of f1, this I shall call it as n1. So n1 will make an inclination of 15 degrees to the plane of contact here, and n3 will be horizontal at this particular location. So these are nothing but the direction of n1 and f1, f of f1, n3 and f of f3. Now moving on to the direction of n2 now. n2, as it is a surface which is vertical, so reaction will be horizontal here. This will be n2 and the reaction n2 will be formed at this particular location. So because this block is been subjecting a force 2.5 kilonewtons towards right hand side, so n2 will be pushed towards right hand side, whereas P will try to push again 100 kilonewton block towards right hand side. This will be the direction of the forces now. Now after this, so we have shown the normal reaction force component. Sulfate here is 100 kilonewton, which is downward. 100 kilonewton shall be shown downward. Then 2.5 kilonewton is towards the left hand side. So 2.5 kilonewton, you can show it towards the left hand side. So these are all the forces pertaining to the individual block component. Now coming on to the last rule, which is nothing but the resultant reaction force component. If you can recall the component here, if I have a sulfate which has been placed here, normal reaction will be acting in the upward direction. If a force P is applied towards the right hand side, frictional force will be opposite, which will be towards the left hand side. Combination of both will be nothing but the resultant reaction R, and this resultant reaction R will make an inclination of phi with respect to the normal reaction. So this was been derived in the previous class. Now coming on to this particular point, as frictional force is upward and normal reaction is inclined here, then x-axis has been drawn in this particular fashion. So here this inclination is 15 degrees, same inclination shall be maintained as 15 degrees. This force I shall name it as f of f1, this force I shall call it as n1. Combination of these both will be nothing but a resultant reaction force. Combination of horizontal force component and vertical force component is resultant. Combination of f of f1 and n1 will be a resultant reaction force component, and that resultant reaction force component is called as R1. Now R1 will always subtend, R will always subtend an inclination with respect to n. So R1 will subtend an inclination of phi with respect to the normal reaction here. So which indicates if you extend this particular line downward, so this will be x-axis and y-axis. R1 is shown in this particular, this is first quadrant, this will be first quadrant, second quadrant and third quadrant. So R1 will be shown in the third quadrant, which will make an inclination of, total inclination will be what? 15 plus of phi. 15 plus of phi, phi inclination is already 15 degrees. So 15 plus of phi, which will be 15 plus of 15. So total inclination here will be 30 degrees. So this inclination, R1 will make an inclination of 30 degrees. Now in addition to that, you also have a force P, which is being moved in the downward direction. Now coming on to this particular force component. Now here the force component is upward at this face. The normal reaction is towards the left hand side. If the force component, which is f of f2, is upward and normal reaction is towards the left hand side, combination of these two will be a resultant reaction for component, what we call it as R2. And this R2 will make an inclination of phi with respect to the normal reaction. Now if we check out the quadrant system here, if we extend the line here, this will make an inclination in the fourth quadrant, first quadrant, second quadrant, third quadrant and fourth quadrant. Please check out. This will be a first quadrant here. If we extend the first quadrant, second quadrant, third quadrant and fourth quadrant. So show a force R2 in the fourth quadrant, making an inclination of phi, and this phi value will be taken as 15 degrees. So these are the forces related to wedge. Now coming on to the forces related to 100 kilonewton. So directly if you have a force in fourth quadrant, you can certainly transfer it even in the second quadrant because of principle of transmissibility. Or else if you have a difficulty, you can take in this particular condition. As the frictional force is upward at this phase, at this junction, frictional force is in the downward direction and normal reaction is towards the right hand side. Combination of these two will yield a resultant reaction, which is R2, which will make an inclination of phi with respect to the normal reaction, which is nothing but N2 here. So this N2, if you happen to observe first quadrant and second quadrant, so N2 will make an inclination of phi, which is 15 degrees. So this is nothing but the value of R2, which has been placed in the second quadrant. If you are able to directly represent, it is well and good, or else you can adopt the concept as f of f2 is downward and normal reaction is towards right hand side. Combination of these two will be resultant reaction, which will make an inclination of phi. And checking out, this will be first quadrant and this will be the second quadrant force. Then you have 100 kilonewton force acting in the downward direction. This is 100 kilonewton force acting in the downward direction. Show that particular 100 kilonewton force. Then you also have 2.5 kilonewton force towards the left hand side. So 2.5 kilonewton force towards the left hand side. Then you have a frictional force and the normal reaction at this phase now. Now if you show the frictional force here at the ground position, f of f3 is towards the left hand side. Why left hand side? Because the block moves towards the right hand side here. Frictional force will be opposite to the movement of the body, so it is towards the left hand side. N3 is upward and combination of both will be nothing but the value of R3, and this R3 will make an inclination of phi with respect to the normal reaction. Now observing this, which quadrant this particular block will fall into? First quadrant, second, third and fourth quadrant. So show a force R3 subtending an angle of phi in the fourth quadrant, and this angle is again 15 degrees. So this is nothing but a diagram for block 100 kilonewton. So we shall refer to this particular diagram, first diagram and then the second diagram, to find out all the unknown. To begin with the solution, we need to check out the number of unknowns should not be more than 2 in whichever diagram we are going to select. Reason behind that is we have only two equations of equilibrium, that is summation fx0 and summation fy0. These are the equations of equilibrium pertaining to concurrent force system. So for that reason, any diagram or any block which you are going to solve should have maximum number of unknowns as 2 and not more than 2. If it had to be non-concurrent force system, then we have three equations of equilibrium, that is summation fx0, fy0 and moment is equal to 0. But looking at this particular diagram, all the forces tends to meet at a single point. So it is an example for a concurrent force system. So we have only two equations of equilibrium. So for this particular condition, we are making use of equations of equilibrium, where for this particular case, we can either make use of equations of equilibrium or else Lami's theorem. Reason it is a point which has only three concurrent force system, whereas here we have four concurrent force systems, so we cannot apply Lami's theorem. So for 100 kilonewton block, we are going to use equations of equilibrium, whereas for wedge we are going to make use of Lami's theorem. So adopting the solution here, now I shall draw this particular diagram again. So diagram will be represented for the solution purpose. So 100 kilonewton again. There is no change in this particular diagram. Whatever the diagram we had drawn earlier, the same diagram we are going to represent. 100 kilonewton force downward. R2 is placed in second quadrant. R2 shall be represented in the second quadrant, making an inclination of 15 degrees. Then extend this particular line. R3 is placed in the fourth quadrant, making an inclination of 5 again in fourth quadrant. This will be inclination of 15 degrees. Then you have a force towards the left hand side, which will be of magnitude 2.5 kilonewton. So these are all the four forces that are available for block 100 kilonewton. So I apply the equations of equilibrium now. To apply equations of equilibrium, if this is 15 degrees, this angle shall be 90 minus 15 shall be 75 degrees. So 90 minus 15 shall come out to 75, because total inclination between x and y axis is 90 degrees. So the remaining left out angle with respect to the x axis will be 75 degrees. So we shall resolve this particular force component R2. As R2 is inward, so vertical force component will be R2 sine of 15 degrees and horizontal force component will be R2 cos of 15 degrees. Then likewise R3 force component, when I resolve, it will have a vertical force component as R3 sine of 75 degrees and horizontal force component as R3 cos of 75 degrees. Whereas the other two forces, 2.5 kilonewton horizontal, no need to resolve, and 2.5 kilonewton horizontal, keep it as it is. 100 kilonewton vertical, keep it as it is. We are going to resolve only the forces which are inclined, and inclined forces are R2 and R3. So that reason we have resolved it along vertical direction and horizontal direction. Vertical direction means y direction and x direction. So I apply summation Fy is equal to 0. If summation Fy is applied, so R2 sine 15 is downward. So minus R2 sine of 15 degrees. Then R3 sine 75 is upward. So plus R3 sine of 75. Then 100 kilonewton is downward. So minus of 100, that is equal to 0. So as a resultant, R2 minus of R2 sine of 15 plus of R3 sine of 75 is equal to 100. If you take it on the right hand side, positive. So name this as equation number 1. Likewise, consider summation Fx is equal to 0. If summation Fx is considered here, as this is a force towards the right hand side, it will be positive. So R2 cos of 15 degrees. All upward forces to be positive, all downward forces to be negative, all right hand side positive, all left hand side forces to be negative. As the force is on right hand side positive, then here R3 cos 75 is left hand side, so minus R3 cos of 75. Then 2.5 kilonewton force is towards the left hand side, so minus of 2.5, that is equal to 0. So R2 cos of 15 minus R3 cos of 75 is equal to 2.5 kilonewton, which is nothing but the given problem. This is equation number 2. Now if you solve this as simultaneous equation, we are going to make use of mode equation 5, two unknowns. So first one is minus sine of 15, next one is sine of 75, then 100 cos of 15 minus cos of 75, then 2.5 kilonewton. So as a resultant, the value of R2 shall come out to 32.67 and the value of R3 shall come out to 112.28 kilonewton, and this value is 32.67 kilonewton. So these are the values of R2 and R3. Now we are going to make use either one of the solution to find out the value of P now. Now to find out the value of P, we shall draw again the wedge diagram. To draw wedge diagram, we shall draw x and y axis. Force P is been applied in the downward direction. Okay, force P is applied in the downward direction. Then R1 and R2. R1 is placed in third quadrant. R2 is placed in fourth quadrant. So we shall show this particular diagram. R1 will subtend an inclination of 30 degrees, whereas R2 will subtend an inclination of 15 degrees with respect to x-axis. And for this wedge, we are going to apply the Lami's theorem. So show this particular force R1 here, which will subtend an inclination of 30 degrees, and R2 which will subtend an inclination of 15 degrees. And here R2 is placed in second quadrant. So here R2 is placed in second quadrant. You are going to place it in the fourth quadrant by making an inclination of 15 degrees. Now here, to make use of Lami's theorem, there are three forces here, P, R1 and R2. Whichever force I am going to consider, divide by the sign of the inclination between the other two forces. If I consider force P, I need to consider the inclination. If I consider force P, I need to consider the inclination between R1 and R2. Inclination between R1 and R2 is this particular part, which is this inclination now. That inclination will be, total inclination here is 180 degrees. So which shall be 180 minus of 30 minus of 15. So as a resultant, 180 minus of 30 minus of 15, which shall come out to 135 degrees. So this inclination is 135. So we are going to write it in the denominator as 135. Likewise, R1 divided by sine of the inclination between the other two forces. If I consider R1, other two forces are P and R2. So P and R2, the inclination between P and R2 will be 90 plus of 15, which shall come out to 105 degrees. So 90 plus of 50 degrees, which shall come out to 105 degrees. So it will be 105 degrees, which will be equals to R2 divided by sine of the inclination between the other two forces. If I consider R2, other two inclination will be P and R1. So P and R1 will be this particular inclination that needs to be considered here. So that inclination is P and R1 is this particular inclination that needs to be considered, which will be 90 plus of 30, which shall be 120 degrees. So this value shall be considered as 120 degrees. So if we solve this particular case, P divided by sine of 135, keep it as it is. Then R1 divided by sine of 105 as it is. Then R2 value is calculated here, which is 32.67 divided by sine of 120. So cross multiplying to get the value of either P and R1. To get the value of P, which shall be 32.67 divided by sine of 120 multiplied by sine of 135, which will be the value of P now. To check out, 32.67 divided by 32.67 divided by sine of 120 multiply by sine of 135, which will give the value as 26.67 kilonewton. So this is the value of P, which is 26.67. Likewise, to get the value of R1 value will be 32.67 divided by sine of 120 multiply by sine of 105, which shall be the value of R1 that needs to be considered, and that particular value will be 32.67 multiply by sine of 105 divided by sine of 120. So we shall come out to the value as 0.866 kilonewton. So this is how we are supposed to solve the value of force P required to be applied on wedge, which is been used to displace a block of 100 kilonewton, and the force P required is 26.67 kilonewton. Thank you. Have a nice day.